Here's something that might surprise you. We can now see signs of addiction risk in a child's brain before they ever touch alcohol, cigarettes, or cannabis. A massive new study just turned our understanding of teenage substance use completely on its head, and it has profound implications for how we think about prevention. I'm Dr. Ferghal Armstrong, and in my decades of working in addiction medicine, I've seen countless families devastated by substance use disorders that often start in adolescence. We've long assumed that the brain changes we see in people with addiction problems were caused by the substances themselves, the neurotoxic effect of alcohol damaging the developing brain, cannabis altering neural pathways, and so on. But what if we had it backwards? A landmark study just published in JAMA Network Open examined nearly 10,000 children, following them from age 9 through to their early teens. The researchers used MRI scans to map their brain structures at baseline and then tracked which children went on to initiate substance use before the age of 15. And here's the kicker. More than a third of these kids, that's 3,460 of them, experimented with substances during this window. But what really matters is what they found in those initial brain scans. The children who later initiated substance use had distinctive brain features that were present before they ever used anything. Let me break this down for you. These kids had larger overall brain volumes, bigger whole brains, more cortical volume, larger subcortical structures. Now, you might think that bigger is better, but it's more complicated than that. They also had thinner areas in the prefrontal cortex, particularly in areas like the rostral middle frontal gyrus. That's a region critical for impulse control and decision making. Interestingly, their cortex was actually thicker in other brain regions like the occipital, parietal, and temporal lobes. Think of it this way. Their brains showed an imbalance. The executive control regions, the parts that help you think through consequences and resist temptations, were thinner and potentially less developed. Meanwhile, other regions were actually more robust. From my clinical experience, this makes intuitive sense. I've worked with countless young people in addiction treatment, and family history is consistently an important risk factor that we see. We've known for years that addiction runs in families, but we've struggled to understand exactly how that works. Is it just the environment, the stress, the modeling of behavior? Well, this study suggests that there's a neurobiological component, actual differences in brain structure that may be inherited or developed in early life. Here's what this means for you. If you're a parent, this isn't about fatalism, it's about opportunity. These brain differences don't guarantee that a child will develop addiction problems, but they do suggest that we need to think differently about prevention. Rather than just focusing on just say no messaging after kids hit their teens, we need to start much earlier with building skills around impulse control, emotional regulation, and healthy coping strategies. For those of us in healthcare, this research reinforces what I've been advocating for throughout my career. We need to view addiction as a brain-based condition, not a moral failure. These kids aren't bad or weak. They may literally have brain structures that make them more vulnerable to early experimentation. The study also challenges our understanding of what those brain scans of adults with addiction actually mean. When we see reduced brain volume in someone with a long history of substance use, we cannot automatically assume it's all damage from the substances. Some of those differences may have been there from the start, part of what made them vulnerable in the first place. The bottom line, early intervention matters more than we realized. If we can identify at-risk children earlier and provide them with the right support, whether that's through lifestyle interventions, skills training, or closer monitoring, we have a real opportunity to change trajectories before problems start. That's all for today, folks. I'm Dr. Ferghal Armstrong, and this has been Cracking Addiction.